Welcome my awesome friend, I hope you all are great. Today's lecture we are going to talk about the motor starting current and how it's going to affect the selection of circuit breaker. So go get your coffee and let's start. First of all, to calculate the starting current, in many places the starting current is being calculated in this equation. I starting or the starting current is equal to 7 times I rated. Of course, this value is wrong, as the starting current may be greater than this value or less than this value. In this lecture, we are going to replace this equation by a standard value according to NEMA code. According to NEMA locked rotor indicating code letter for the electrical motor, kilovolt ampere drawn by the starting current is equal to kilovolt ampere code ratio times the motor mechanical horsepower. So all you need to do is to get the nameplate of the motor like this, and you are going to see on this nameplate kilovolt ampere code. This kilovolt ampere code like this called G. Then after that we are going to get a value of the code ratio. We are going to put it right here and multiplied by the motor mechanical horsepower, which is given also by the nameplate of the motor, and put it right here in this equation. At the last we are going to get the value of kilovolt ampere of the starting current. From the NEMA code letter, we are going to get the value of G. G is between 5.6 to 6.29, the value of kilovolt ampere per horsepower or kilovolt ampere code ratio. Or approximately at the mid value is 5.9. So the starting kilovolt ampere is equal to 5.9 times the value of horsepower is 40 horsepower. So we are going to get 236 kilovolt ampere. This value is the starting value of the motor. The starting current I starting is equal to S over V times root square of 3. So 236 times 1000 over 400 times root square of 3, we are going to get 340.6 ampere. So the value of the starting current of this motor is 340.6 ampere. Of course, you can note right here the value of the rated current is 56 delta value, and the starting current is 340.6 ampere. The starting kilovolt ampere required by motor starting at the full voltage is determined by the nameplate or the manufacturer. In general, the kilovolt ampere can be given by the manufacturer or nameplate, or you can use these values if you cannot find it on the nameplate. If it's less than 1 horsepower, the kilovolt ampere code ratio is L, and if it's between 1.5 or 1.5 to 2 horsepower, we are going to use L or M, and for 3 horsepower use the code K, and for 5 horsepower use code J, and for horsepower between 7.5 to 10 use code H. And finally, if you have a horsepower greater than 15, you use the code G. Of course, the smaller motor requires higher starting kilovolt ampere. You can see it. When we go for less horsepower, you can see the kilovolt ampere ratio is increasing. Now, how we can use this value in the selecting of the circuit breaker. The circuit breaker has two tripping, which is thermal tripping IR and the magnetic tripping IM. The magnetic tripping IM must be greater than the starting current of the value of the motor. So if the starting current flows through the circuit breaker will not trip in starting condition. Okay guys, that's for today. Thank you for watching. See you in the next lecture. Bye bye.